Please. Okay, so a lot of people are able to just do this at this point really quickly, but once again, if not, it's not how quick you get there, it's just that you can get there. So because they're all log to the base 5, we'll put this as 1 log to the base 5. Any positives go on top, and any subtractions go on bottom, right? So you had x cubed, then you had a square root of y, and then on bottom you had a z squared and a cube root of 2. Who got it right? Raise your hand. Nice. Cool. Then with this one, we had our ln of the root x plus ln of y minus ln of 4, which then, yes, you would then take this exponent in front, 1/2 ln of x plus ln of y minus ln of 4. Now, I like to be in the habit of using parentheses, even though it is not necessary. Okay, let's begin the lesson. Okay, take a picture of this or write it down very quickly. So, we're going to be solving logarithmic and exponential equations today. This is a really pretty basic idea because we've been solving equations all year and the ideas work hand in hand with what we've already done. So, everybody, the first step is to isolate the logarithm or isolate the exponential. Just like when we were solving radicals, I said isolate the radical. You'll do that same thing with logs and exponentials. Get it all by itself. Now understand, to undo a log, you have to have only one logarithm. So you might have to get all the logarithms on one side of the equation and put them together using properties of logarithms, because that's why we learned them, so that we can put them together, write it as one logarithm. And then once you have one logarithm, you can then undo the logarithm. So then once you do your second step of undoing the log or exponential by the correct inverse, which we know they're inverses of each other, then you would just solve for x using algebra, just like we did once we undid the radical, we solved for x. Same idea. And then fourth, whenever we're solving any type of equation, and we're doing stuff to both sides of an equation, you've got to check for extraneous solutions. So, everybody, there are problems. Logarithms, based on, we know that a logarithm has a vertical asymptote at 0, and it looks like this. They're not going to be negative, right? We're not going to have a negative number inside an ln or inside a log. But don't be mistaken, so we won't have a negative number inside ln or log. But don't be mistaken, because just because we get a negative answer doesn't mean when you plug it back into the logarithm that it stays negative, because algebra sometimes will fix it. Here we go. So just look up here. So this is solving an exponential equation. So we isolate the base. Well, base is isolated, isn't it? Oh, yeah. Good idea. I've never had someone ask that. That is exactly what we're going to do. So we could use the zero product, or that rule we were using. I like the idea. If they're the same base, can't we just say that these must be equal? So I usually do this. I use algebra to undo e, so I would ln both sides. So then ln and e cancel out. We have negative x squared equals ln and e cancel out, negative 3x minus 4. Adam, way to think of that. Same thing. Yep. So now we have a quadratic. We want to solve it. Remember, it is always better to have positive x squared. I'll bring that over this way. 0 is equal to x squared minus 3x minus 4. We'll solve the quadratic by factoring. What multiplies to be negative 4 and adds up to be negative 3? 1. Yep, 1 and negative 4. We quick factored this to be x plus 1, x minus 4. Therefore, x equals negative 1 and x equals 4. Now, I do want you to have your calculator out ready to help me check these. But watch, checking these answers will be pretty easy. Now, guys, when you hand in this test, you should know what your score is going to be, because it is so easy to check your answers for almost every lesson, as you've noticed. So watch how I would check this. Okay, I would say, okay, I'm going to check x equals negative 1. So watch. E raised to the negative 1 squared. Does that equal e to the negative 3 times negative 1 minus 4? Look, isn't that e to the negative 1? Because negative 1 squared is 1. Negative 1 equals, let's calculate this. So 3 minus 4 is, so we have e to the negative 1 equals e to the negative 1. Isn't that a true statement? And then you could do the same thing with 4, and it would be negative 16. and negative 16. So we're good. Okay, cool. Let's do another one. Okay, so this is an exponential that is not e. So we need to isolate the base. Get the base all by itself. So we would divide by 3. So then we would have 2 raised to the x power equals 14. Now we cannot bring down this x without undoing the base. So wouldn't we log base 2 both sides? Log base 2. So then over here, log to the base 2 and base 2 cancel out. So we have x is equal to log to the base 2 of 14. Now from there, we would need to use our change of base formula, which would be log of 14. Thank you. And then that is how your ACT would leave the answer. Yep, but I'm also going to have you leave the answer and give me the entire decimal. Go. Sweet. Are we good? Now I want everybody to take that. You've all typed it in. Watch how easy this is. Type into your calculator 3, do a parentheses 2, and then hit raise to the, and then do second negative sign, and that will put in the last answer, so you don't have to retype it in. Then hit enter. It is 42. Okay, let's do this one. What should I do? Yep, isolate the base. So watch, we would have e to the x equals, then what would I do? ln both sides. So now we would have x is equal to ln of 55. ACT would leave it like that, you would leave it like that, and give me the decimal. Thank you. Everybody go, type it in. E to that answer, so you'll go e to the second answer, plus 5, hit enter. You better get 60. All right, let's do this one together. So what should I do first? You guys just lead me through it. You got to make sure you use that exact thing. Well, it was close. Yes, it worked. Yeah, make sure you use the full ln of 55. Okay, what should I do first on this one? Add 4. Watch, because this is going to come out. I'm going to show you how you would need to write your answer. So we have 2, and then times 3 raised to the 2t minus 5, and then we have equals 15. What would be my next step? Okay, so then we have 3 raised to the 2t minus 5 equals 15 halves. Leave it as a fraction. Then what? Yep, log base 3 both sides. Is everybody with me? Log base 3. Log base 3, let me show you how I would expect you to write it. So those undo each other, so then 2t minus 5 drops down. That's equal to, right now we have this, log of the base 3 of 15 halves, don't we? Now what you should do from there, and what your ACT will do, is they will leave it in terms of log. So isn't this 2t minus 5 equals, we need the change of base formula, log of 15 halves divided by log of 3. Does everybody see how that's the same thing? Okay, now what would be my next step? Good, add 5 to both sides. So we have this, 2t equals. This is how I want your answers. Then what? Divide everything by 2. Everything by 2. So there's your answer. That's what I'd want to see. Now I want the decimal as well. Now here, everybody take my suggestion. Do not just try typing that into your calculator and like not hitting enter or anything. You're going to get an error by not typing it in right. So do this divided by this, hit enter. Then add 5, hit enter. Then divide by 2 so that it does it correctly. 3.14? Okay, and then it goes on and you would write down the full decimal. Now let's go up and save that answer and then go up and check it. Everybody take that time to check it. So, does everyone need to see this still? I know, but I gotta wait. Is everybody good with this piece? Okay, go try checking it. This is where it gets a little bit more advanced here. Okay, so I want you to notice something. We have e to the 2x minus 3, e to the x plus 2 equals 0. Now here's where it's an issue. So if this was an e to the x and an e to the x, we could put those together, you know? But they're not the same exponent, so you can't combine them. So here's the other problem. Even if I subtract 2 over and then factor out an e to the x, there's still going to be an e to the x inside. Does everybody see what I'm saying? So we can't solve this one by isolating e. Now, I want to point something out. Does this remind you of something that looks like this a little bit?
Yeah.
Does that kind of look similar in a sense? Yeah, it does. So think about it. If I take and say, I'm going to let u be e to the x, then what are we looking at here? Now, don't let this part throw you off. So isn't that e to the x squared? Because raise a power to a power in u, multiply. So then we have minus 3 e to the x, and then plus 2 equals 0. And now can't I do, since I said let u be e to the x, can't I do a U-Substitution? So now what I really have here is u squared minus 3u plus 2. Everybody see? And now I can solve u. And then once I know u, I can go back and solve for x. So let's solve for u. We would solve by factoring. Well, multiplies to be 2, adds up to be negative 3. So u minus 1, u minus 2, therefore u equals 1 and u equals 2. Now, you'd say, okay, that's u, but I need x. Let's go plug that in. So I'm going to go right here and say, okay, so I have 1 equals e to the x, and I also have 2 equals e to the x. Now solve for x. ln both sides. So, good, way to remember that. So we have ln of 1 equals x, which is 0. X equals 0 here. Then right here we would ln both sides. So now we have x equals ln of 2. So we have two solutions, ln of 2 and 0. So let's type those in and check them. You go for it. How do you suppose we would do this one? I bet you can tell me without even having an example. Base e both sides. So now ln and e undo each other. X equals e to the third power. You would leave your answer in terms of e, but then also give me the decimal. Go, e to the third power. Sweet. Did we all get it? Now, everybody, you should go to your calculator, do ln of second answer, and then hit enter. 3. Yay. You know you got it right before you hand it in. Hey, you guys, what's this answer? E squared, doesn't it? Okay, let's do another one. All right, any suggestions for me? There are 2 ways to solve this one. You could, and then you could put them together. Yeah. I like that idea. I like Joseph's idea. There are 2 ways to do it. Yep, Joseph says, isn't it appropriate to base 3 both sides? Yep, that cancels out with that. So we would have 5x minus 1 equals, that cancels out with that, x plus 7. And now solve for x. Subtract x, add 1. So then we would have 4x equals 8, therefore x equals 2. Now checking this one would take the, well, it wouldn't even take the change of base formula, because let's see if it's a true statement. Plug in 2. We would have log to the base 3 of 5 times 2 is 10, minus 1, so we got log to the base 3 of 9 on the left. Now plug it in here. Log to the base 3 of 2 plus 7 is 9. Do you see how it's a true statement? Cool. Yeah. If we don't have base 10, your calculator can't calculate it. So then we'd have to do log of 9 divided by log of 3. But you see how right here we already see it's going to be equal? Cool. All right, looking at this one, guys, everybody listen, because this is very important. Notice something here. We have log of the base 6 of all that stuff minus log of the base 6 of 5. Let me show you what is equivalent to breaking the forbidden rule. If I said I'm just going to base 6 that, base 6 that, that's equivalent to doing, I'm just going to square that, because you cannot do it across an addition sign, correct? So we cannot base 6 across a subtraction sign. That would not be mathematically correct. So instead, we've got to have one logarithm to undo it. But can't we put these logs together using properties? So this is log to the base 6 of 3x plus 14 divided by 5, and that's equal to log to the base 6 of 2x. Yeah, now we can base 6 both sides. So then we have 3x plus 14 over 5 equals 2x. Now how would I solve? Okay, good. Multiply by 5. 3x plus 14 equals 10x. Then we would subtract 3x, wouldn't we? 14 equals, therefore x equals 2. You could check to make sure it was a true statement, but all is good. Hey, you guys do this one by yourself. Leave your answer in terms of e. Did you get e is equal to, x is equal to e to the negative 1/2? Yeah. Which on an ACT or on a test, you should go 1 over e to the 1/2. Just if I said leave your answer in terms of e. Now you would type that into your calculator and it will give you a decimal. And then it kept going. Now you can go check it. You could go check it. Do we have any questions on that one? Because I can help. Okay, we're doing good on time. Okay, how about you guys go for this bad boy all by yourself? Leave your answer in terms of not the decimals. 2 ways to do this one. This is the easy way. What'd you do first? Divide both sides by 2. So then we have log to the base 5 of 3x equals 2. Did everybody do it this way? You did it a different way? Hey, awesome. You're going to be my second way of doing it. You're awesome. Hey, then right here, what would I do? Base 5 both sides. So then we have 3x equals 25. Therefore, x equals 25 over 3. Awesome. Now, Eric did this differently. So, Eric, what was your thought process? Isn't that true, everybody? So that is absolutely great. And then what did you do, Eric? So you base 5 to both sides. True. Okay, so then you had this. 3x squared equals 5 to the 4th, which is 625. Then what did you do? Square root. Okay, awesome. So then we had 3x equals plus and minus 25. And then what? Divide by 3. So with this method, we got 2 solutions. 25 over 3 and negative 25 over 3. Well, let's check it. Let's check it. If I plug in 3 times negative 25 over 3, won't that be negative 25 inside? Can't happen. So that would be an extraneous solution. And look, we really did end up with the same solution. See? Yeah, but then the one was thrown out. So we ended up with the same answer. Both methods work equally. They're both mathematically equal. Awesome job. Hey, all right, go for this one. So let's make sure you're good with this. You should have put this log together and you should have 5x times x minus 1 equals 2. Did everybody get that far? Yep. Then you base 10 both sides. So then you had 5x times x minus 1 equals 100. Did everybody get that far? If not, I can go slower, but I'm trying to not waste your time, but I can go slower. Is everybody good up to there? Sweet. Now, we couldn't square root it or anything because there's a bunch of stuff going on. So you would multiply that in. 5x squared minus 5x equals 100. Then what? Good. Subtract 100 because it has to be equal to 0. Then I would personally like to quick factor, so I'm going to pull out a 5x. No, I mean a 5. Pull out a 5, then left is x squared minus x minus 20. And now with solving, can't I divide both sides by 5? Yeah. So now that's why that 5 does not matter mathematically when solving. Does everybody agree? So we're just solving x squared minus x minus 20. So what multiplies to be negative 20 and adds up to be negative 1? So x minus 5, x plus 4, therefore x equals Okay, let's check them. If we plug in 5, all is good, all is good. Let's plug in -4. 5 times -4 is -20. Yikes. Can't happen. Can't have a negative inside a logarithm. So we throw that answer out. Try typing it in. Your calculator will say error. That's an extraneous solution. Let's put that on the video. Yes, everybody, you need to, this is a valid and great question. You have to check your answers in the original because this is the manipulated equation. You know, you can't plug it into the manipulated one. You got to plug it into the very first original to check it. Okay, awesome. Moving on. Okay, these are the last couple. There's like 3 more examples here. So this is where the story problems come in. So it says, you have deposited $500 in an account that pays this much interest, compounding continuously. Automatically, when you see those words, you should say, okay, I'm using this formula. Yeah, PERS. So let's plug in what we know. It says, how long will it take to double your money? So we're going to be finding the time is what we're going to be trying to find. Let's plug in what we know. We're depositing 500. E, what's our R? We don't change R. 0.0675 T. Now, it says, how long is it going to take to double your money? Well, how much is going to be in the end? If it's doubled, yep. So now solve for T. Does everybody see how this is no different than what we just did? Good. Isolate E, divide by 500, divide by 500, giving me a 2 equals E to the 0.0675 T. Then what? ln both sides. So we have ln of 2 equals 0.0675 T. Last step. Okay, so everybody start typing that in. So 10.26 years. That will be how long it takes you to double your money. Now, on an ACT, they will a lot of times get in 2 months. So remember, this 0.26, a lot of people will get tricked, and they'll have the answers 10.2 months. That is not necessarily true. This 0.26 means 26% of a year. So take your 12 and times by 0.26. So how many months really? 10 months and, 10 years and 3 months. And then a few days, we could even get into days, but we won't. You could even get into the second that you will finally reach that double, that $1,000, yes. What's the rule of that? I didn't know that. So that's a really cool interesting fact. Kind of cool. Yeah, so yeah, that's probably true. I don't know anything about that. That sounds cool though. Awesome. Probably. Awesome. I didn't know that. That's cool to know. Okay, let's do this one really quick. It says, suppose $10,000 is invested at a 6% interest compounded annually. That's not PERS. Isn't that just once a year? Now, they made it too easy, and they gave you the formula. I'm going to hurry and scribble it out. Okay, it says, in T years, an investment will grow to the amount expressed by the function, but it shouldn't have said that. So the interest rate is 6%. So wouldn't this be our formula? We're starting with 10,000, am I right? And then 1.06 would be an increase of 6%, right? Yearly. Then we would have a T. And then how long will it take to double? So we would have our 20,000. And since I don't know that little rule, I'm just going to use my math skills. So wouldn't I divide both sides by 10,000 now? It doesn't say compounded continuously. Compounded annually. That's once a year. That's this. We could, and we'd end up with this because it's only happening once in a year. Does that make sense? These are the ones where if it only happens once in a year, you can just straightforward go. Okay, so then we would divide by 10,000. So we'd have 2 is equal to 1.06 to the T. What should I do next? Log base 1.06 both sides. Log base 1.06. So then we have this. Log to the base 1.06 of 2 equals T. So don't we need to change your base formula? Log of 2 divided by log of 1.06 and how much time? $11.9 years. And let's just go with that. And then if it needs to get in a month, we could, but we're good. Okay. This is actually really, truly how they talk about earthquakes. If you became I don't know, what profession looks at earthquakes? A what? Something. Yeah. There are, meteorologists study weather, so I don't think that's a meteorologist. Oh, cool. Awesome. Okay. So this is truly, like this is literally how you could look at it this is like such a cool real world problem because it's not just made up out of kicks and giggles. It is like literally, truly true. So this is actually truly 2 earthquakes that happened. So it says in December of 2004, an earthquake with magnitude 9.3 on the Richter scale hit off the northwest coast of Sumatra. So here's a picture of Sumatra. So in 2004, there was really this earthquake, everybody, and it had a 9.3 magnitude on the Richter scale. Then a year later, these poor people had another earthquake, and it had a magnitude of 8.7. Now, don't those seem like they would be pretty close to the same intensity? Like, wouldn't you suspect that based on how close they are, the damage that was done would be pretty equivalent? Well, you'll see that it actually is significantly different. So everybody, it says, here is the formula to look at magnitude and intensity levels, and this will help us compare how intense one was versus the other. So it says, how much more intense was earthquake 1 than earthquake 2? Well, let's do some math here. So let's plug in what we know. Log of intensity 1 divided by intensity 2 equals magnitude 1 minus magnitude 2. So we would do 9.3 minus 8.7. So we're looking at log of intensity 1 divided by intensity 2 equals 0.6. Is everybody with me? Because you can hear you talking in my video and you're ruining it. Are we almost there? What should I do next? We're trying to compare intensity levels, so what should I do next? Base 10 both sides to undo the log. So now type into your calculator base 10 raised to the 0.6. 3 point what? Okay, cool. 3.98. So guys, look at what this is literally saying. Now, couldn't I take and multiply up intensity 2? Everybody? Mathematically. So look at what this literally says. Intensity of the first earthquake is equal to 3.9. I'm going to say it 4 times as intense as the second one. Do you see how that literally reads? Intensity of the first earthquake was 4 times as more intense than the second. Does everybody see? Isn't that crazy? So the first earthquake was literally 4 times as intense, and they were only very different in their magnitude levels. Does that make sense? 0.6 difference. That was barely anything. Does everybody see? So it's crazy how quick, but think about why that is. Isn't it because it's exponential? So think about how quick. It's base 10. So think about how much of a difference that makes. Does everybody see how crazy that is? So if you were to look up on the internet like pictures of both earthquakes, the first one caused so much more damage, even though they were really close in magnitude. Cool. All right, last one. So this is the last one. Did you write down that log equation? You might need it. That's how you, this one is how the formula you use for intensity levels and magnitudes of earthquakes. Okay, it says the pH of a substance equals negative log of H plus, where H plus is the concentration of hydrogen ions for period. H plus, so the concentration of hydrogen ions for household ammonia is 10 to the negative 11. The hydrogen ions for vinegar is 6.3 times 10 to the negative 3. It says, what is the difference of pH levels of ammonia and vinegar? So let's go out to the side. Ammonia. Let's figure out the pH level of vinegar. So everybody, the formula was this. pH will be equal to negative log of H plus, which is our hydrogen ions. So they said ammonia has how much H plus? So we have negative log times 10 to the negative 11. So without a calculator, what is that going to be? Yep, so that cancels out. So then won't negative and negative become positive? 11. The pH level is 11 of ammonia. Let's do vinegar. So we would have pH is equal to negative log of 6.3, then times 10 to the negative 3. You're not allowed to use a calculator, so let's kind of, for a second, can't we, if we wanted to split this apart, multiplication? So this is equal to negative log of 6.3 minus log of 10 to the negative 3, which equals negative log, so I made sure to distribute the negative, that's why I did negative. So negative log of 6.3, and then won't this become plus 3? And now type that into your calculator. What is it?
Much lower than
Yep. 2.2. Sweet. So now it says, what is the difference? So you would take 11 minus 2.2, and that would be your answer. Are you sure you got 2.2? A difference of 8.8. So then the difference is an 8.8 pH level, which, whatever that means, I'm not a chemist. I say it? A chemist. Okay, cool. A physicist, chemist, same thing. Hey, that's the end of the lesson. Here are the problems. You should be working like a maniac. You can get online on your phones, and it's pretty